Hi, my name is Charlie Thomas from Campbell-Sevey, and I'll be talking about steam distribution coils. This is a steam distribution coil. This is the pressure-containing parts where we contain the steam, and then the air blows across here. In terms of piping, this would be our steam inlet, this would be our condensate outlet, and then we've got one other connection for a vacuum breaker or a thermostatic air vent. And then these are the connections. This is the header, and then over here we've got tubes. The tubes go into the face area. The tubes then are mechanically bonded to the aluminum fin in this case. And then the air blows across the finned area in order to heat up the air. You can see on the back side, the tubes are just plugged at the ends. So you're wondering how we get steam through the tube area. This cutaway, you can see that the steam goes in here, hits this baffle plate to provide good steam distribution. It's got a header inside of an outer header. This inner header is the steam containing header, which distributes the steam into these smaller diameter tubes. These smaller diameter tubes travel down the length of the coil, and they're perforated along their length to allow the steam to come out to the outer tube. It's the outer tube that's in contact with the finned area, and that's where the condensing occurs. Then that condensate travels down the outer tube to the outer header, which is then connected to the condensate connection. Then the condensate drains out and goes to the steam trap, which is piped downstream. Because this outer header is our steam condensate header, that's where the condensate velocity or steam velocity is near zero. That's a good place to pipe in a thermostatic air vent and vacuum breaker. The air, of course, does blow across here where it's heated. These can be found in many areas. Comfort heating, where we're just worried about heating of building air, from hospitals to universities to office buildings and apartment buildings. Or they can be used in process air applications where you need to heat up air for an oven, for example. Or you've got a dryer where you're taking liquid, a spray dryer where you're taking liquid particles and turning them into a powder in a food application. We offer many different materials. We can get connections, headers and tubes made of copper or carbon steel or stainless steel or copper nickel. And we can get our fins made from aluminum or copper or carbon steel or stainless steel. You typically on process air heating applications where you're heating up air to high temperatures, want to maintain a similar material between your tube material and your fin material to cut down on the problems you can have with differential expansion of different materials. Tube diameter on steam coils, steam distribution coils, can be either 5/8 inch or 1 inch. We need to allow, because they're larger diameter, we need to allow space inside the tube for that smaller steam distribution tube. These coils are available in small sizes, maybe 6 by 6 inches, all the way up to 90 inches tall. With a 5/8 inch tube, we typically max out at 6 to 8 feet in length. Otherwise, 1 inch diameter tubes can go longer than that.